Hey guys, so we're going to be talking about the different types of cell transport. And as you're viewing this presentation, you should be completing your diffusion osmosis doodle notes. So we're going to go ahead and start with diffusion, which is the top portion of your notes. So diffusion is the movement of particles from an area of high concentration to low concentration. And it's pretty random, but it's a constant movement. So if you look at this picture here, you see that it's tightly packed, high concentration, and it disperses out to the area of low concentration. And again, kind of if you look here, you have food coloring added, high concentration when it's first added to the water, dispersing to the low concentration where there is no food coloring, and eventually dispersing throughout the entire liquid. So diffusion, if you can really remember it, it's just high to low. Things moving from high concentration to low concentration. So it does this in an effort to reach a state of evenness or equilibrium. And what that means is just that the molecules are evenly distributed or spaced out within that substance. So we have high concentration, the food coloring here, the water with no food coloring being low concentration. Eventually it spreads and disperses out until you reach a state of equilibrium. High to low, high concentration moving into the area of low concentration to get a state of equilibrium. So there are lots of examples of this in the real world. I'm sure you could think of many. An example would be making Kool-Aid or making like hot chocolate or chocolate milk when you're adding in a powder or substance into a liquid, and it kind of sits on top of the liquid at first, and then eventually over time as you shake it or stir it, it eventually distributes throughout the rest of that liquid. So you have been practicing diffusion for probably most of your life and just not realized that this had a name. So what you're going to do now is on your notes where you see the 2 teacups, you're going to draw in a tea bag in the water to simulate high concentration, the tea in the tea bag, that has not dispersed out to an area of low concentration. And then in your other teacup, you're going to draw what it should look like when the tea has distributed out into the water. So when the tea is now moving from an area of high concentration to the area of low concentration. And you could also think of this too, how the temperature of something might affect the rate of this diffusion. So if you think about it, if you were to make hot tea versus cold tea, do you think that the rate of diffusion is going to change or be affected by the temperature? So that might be something you could test out at home. So how do we make this kind of tie into what we've been talking about? So we've been discussing organelles, we've been discussing these different processes. Well, if you think back to your life processes, one of the things was all living things have movement, and part of that movement was cellular transport. So when you look at a cell and you look specifically at its cell membrane, you see that this membrane allows certain things to come into the cell and leave the cell. And so we like to call this membrane semi-permeable or selectively permeable, which means again that certain things are being allowed in and other things are not. So when you have this natural process of particles moving across this membrane, we call this diffusion. When there's no energy required, you're naturally just moving from an area of high concentration to an area of low concentration to reach a state of equilibrium. So now we're going to move on to osmosis. And if you can remember diffusion, then you can remember osmosis, because osmosis purely has to do with the movement of water. It's the diffusion of water now. So before diffusion was talking about any type of substance moving from an area of high concentration to low concentration. Osmosis is specifically pertaining to water, and water diffusing across a semi-permeable membrane. And we've used that term again meaning that it's allowing certain things through easily and other things not so much. So if you look at this image here, you see that the water particles or molecules are moving through very easily, back and forth, whereas the green dots here, these other molecules are not. They're too large, or they may require some sort of energy to allow them to pass. They may require a gate or some sort of receptor protein to allow them to enter or exit the cell. but water does this very easily. So again, there are lots of examples of real world where this occurs, but one that's probably the easiest to see is placing a gummy worm in a bowl of water or in a cup of water, or a gummy bear and some water. And what we see is that if you think back to high versus low concentration, you have a gummy worm that has a low concentration of water. You have a bowl of water that has a high concentration of water. So naturally the water begins to do this movement where it fills in the gummy worm, moving from an area of high concentration to an area of low concentration, eventually causing the gummy worm to expand. Because the gummy worm has a semi-permeable membrane, it allows this movement of water very easily. And that concludes our set of notes. It's very brief today, very simple set of notes. But again, if you ever have any questions, please make sure you direct them to your teacher.